really popular topic when it comes to when I say to people, what do you fear most of maths? Probably the highest number of people, I'm not going to put it in a fraction or a percentage, but the highest number of people will say, oh, I'm rubbish at fractions. And fractions, when it comes to level two functional skills, is not as complex as what we think. Um, I
Definitely not.
think Yeah, I do think that at school there's some real in-depth kind of, at GCSE there's some real in-depth fractions going on, and there's no at functional skills level two, there's no need to kind of go so deep. So when it comes to kind of like the questions you were going to get, again, I can't uncover my answers because it's a PDF now. We've got the sort of questions where I think we did one the other day where it said a fraction of people are having tea, a fraction of people are having coffee, how many people are having hot chocolate, and it is questions like that in your non-calc that you'll get fired at you, and it won't be like looking like this where it's just the numbers. It'll be dressed up in something. So if it's dressed up in something, forget about what it's dressed up in when we're talking about hot chocolate, you know, whether people like, to know, fish or chips or whatever. Just look at the numbers and work with the numbers. And as we look at all these numbers, we can see that not one of these numbers are the same. So we're going to have to do something with all of them. And of course, yes, we can do the um, crisscross method if you wish. I I don't know. I didn't learn it at school, so it never got embedded to me where we do the crisscross method. I don't know if I'm happy to teach it, but I just like my method where I will do them. I'll try and give out enough space. I've only got 8 to do here. Okay, let's do one here. I think we can do 2. Actually, let me just do it. If I do it in a dark color, no, I think I'll stick to me light, me green color, but do it here. So if we've got 2/5 and we've got a half, we can see that those two numbers don't match. So we need to find a number where they do match. The quickest way to do that, and I know it doesn't always work that it's times those two by each other. There's sometimes a number that comes before that. So if we times those two together, we're going to get tenths. Okay, so we've got tenths, and I'm still adding them. And whatever we times this number by to get to 10, so we did 5 times 2. So we're going to do 2 times 2. And 2 times 2 is 4. And when we look at a half, well, do we need to? But 2 times 5 got us to 10. So 1 times 5 is half. But we should know that 5/10 is 1/2. We just half of whatever number, isn't it? And now we've got that. We can clearly see that 4 add 5 is 9. And the 10 remains the same. So if it was a question saying, oh, how many people like hot chocolate? Well, it'd be 1/10 because there's only 1/10 left. And these ones, they're meant to be quick firing, so we know the process of what to do. Again, we'll try and do it. We'll do it up here. We'll see if we can go round to 7. Again, we're straight away looking at, oh, 2 and 7, they're not the same. Well, if we go double 2 times 7, it's 14. Generally, if one's an odd and one's an even, the easiest way to do it is times them both together. And we'll get to, and this is still an add. And whatever we times that one by, 2 times 7 to get to there. So 2 times 2 is 4. That's a half. So we know half of 14 is 7. Add those two together. Oh, I'm going to squeeze it underneath that little person. What else have we got? Which one have we got that's different? They're slightly different. We'll get to that one in a second. Let's do a takeaway one, because let's add very similar. Change them both to 6th. And we can see that half of a 6 is 3 and a third of a 6 is 2, so that'll be 5/6 altogether. And what I am doing, I'm looking at these numbers and I'm thinking, well, I can't make that smaller because 9 is not an even, so I can't divide it by 2. 10 is, and 9 divided by 3, but 10 doesn't. Likewise with 11/14, 11's a prime, so we can't divide it by anything but itself or 1. So let's go to the first takeaway. Exactly the same concept. 5 4, and then 2/3. We can't do anything with those, so we're going to times them both together. We're going to get 15. And when we look at that, whatever we times 5 by to get to 15, we can times 4 by, so we times 5 by 3. 4 times 3 is 12. We times 3 by 5, so we times 2 by 5, 10. It becomes 12 take away 10, 2/15. Again, we can't shrink it because 15 doesn't divide by 2. Take away. So this is the one I'm looking at. We can see now that all the bottom ones here, if we were to just choose one, we'll go to the first one, and we'll do one of the 8/9 take away 1/3. I don't need to times these two numbers together now, because I know that 3 is part of my 9s. 9 is part of my 3, sorry, way around. So I can straight away keep my 8/9, but I can now change just this one. So I'm going to change that to 9th. And again, whatever I times that one by to get to there, which I times it by 3, I am doing that one times it by 3, 3/9, and I just take away like I would normally. 8 take away 3 is 5. And I've got my answer. Same with this one. Look, that I don't need to change this one. I can just change that one. So I change that one. That would go to 6. I times that by 2, so that's 4. So that answer would be 5, 6. Likewise with this one, look, I'm already in tens here, so I doubled that one to get to 10, so I'll double that one. And I've got 3 add 4 is 7/10. And then same with this one, because 8 is part of my 4s, so I can keep my 8. I just need to make sure my 4s is up there, so I doubled 4 to get to 8, so I need to double my 1, which is 2, and that equals 5/8. And all of the numbers that we just seen here do not shrink. Prime number 5, only 1 in itself. 6 obviously does. Prime number 7 and 1 only go into it, and then prime number 5 again. So we know that when we have a 1, a 2 as such, a 3, a 5, a 7, 11, a 13, a 17, 19, prime numbers don't shrink. So if you've got any of those numbers on the top of your fraction, you know for a fact it's not getting any smaller. Also on the bottom as well. We'll see if you got one on the bottom. Right, let's scroll. So that would be like the extent of the last lesson that it got to. It got to the extent of where we're learning to add fractions, hopefully, by understanding we just look at the denominator, and whatever action we do with the denominator, we do with the numerator, bottom number, denominator, numerator, top number. So what I want to do now is look at the equivalents, because like yesterday when I said, oh, I'm just going to times it by 0.75, which will be 3/4, or I'm going to times it by 0.2, which is 20%, which would be 2/10. You know, little things like that, or a fifth. It's a case of not having to spend too long understanding what the equivalent is. We've got values here. If we look at a half, when we think of a half, I don't think of that because that's not a half. I think of it as being that. So that one is the incorrect one, obviously, when it says which one is Yannick correct. No, he's not correct. 50% is a half, as is 5/10. It's just literally that one's boosted up by times 5. So that one is boosted up by times 5. It doesn't matter if it's 16/32 or it's, I don't know, 100/200. If the top number is half of the bottom number, then it's the equivalent fraction. It's the same fraction. Whereas that one, as we can see, that's the odd number out, 0.05. When we look at our percentage, we look at it as how many parts of 100 is my 0.05. It's 5 parts, so it's 5%. Whereas our 50% is 50 parts of my 100. Obviously, it doesn't have a 0 on it because you don't need it. But when we're looking at how much, when we're talking about how much of the percentage does it represent, my 1.00 is my 100. And so you just write your number underneath the 1, and you can see if it's 5%, 20%, 33%, or whatever, anything like that. Okay, and we're going to skip that. We're going to look at the equivalence table. Hopefully that's yeah, we could look at that one. That's quite good. When we look at this one, for me, there's one that stands out here that I think I said I don't like it the other day. I mean, we know that half is 50%, so that one's true. 0.01, 1/10. Again, put my 100. That's a bit of a, you can't really see that much. Look at it as part of 100. It's only one part of 100. That's not saying one part of 100. That's saying one part of 10. If it's saying one part of 100, it'd be that. So we know that one isn't correct because that's saying one part of 100 and it's not. 1/3. So when we divide 100 into 3 pieces, do we get 30, 30, and 30? No, because if we did that, that's 90. So 30% of 100 is 30. 1/3 of 100 is 33.33333, and I'll keep going on until I run out of page. So 1/3 is not 30%. 1/3 would be 33.333, and keep on going forever. So that's the one where people get wrong quite commonly. The other one they get wrong is well, we're going to look at it in a second. 1/20th and 1/5. Sometimes people say, well, 1/20th is the same as a fifth. No, 1/20th, when we divide 100 by 20, we get 5. So 1/20th is 5%, whereas 1/5 is 20%. So it's kind of like the opposite, and we get them mixed up. I think I'm running over my charging cable, but I don't mind. It's not the end of it, it's just the wire. So it's 0.42/5. How do we know? How could we work that out? Well, we look at if it's 20 parts in 50. Let's double that one so we get it to line up with 100. So let's double that one. So we're getting the equivalent fraction as part of 100. So now we know that 2/5 is 40 parts in 100. Let's line our number up. So 0.4 is 2/5 because when we line it up against 100, we can see, obviously it doesn't have a 0 in it, but it's got 40 parts out of our 100. There we go. So 0.4 is equivalent of saying 2/5. So that one is also correct. So we've got 2 correct and 2 incorrect. I would say that one is probably the most common one that people make a mistake at in a question. There's only been one question we've had that in the last sort of 2 weeks, so it's not like the question comes around often because they're not there to trip you up. There you go, that's just a confirmation. Again, looking at how and why. If we look at some of these, we can definitely see, we know that 0.25 times that by 100, we get 25%. Or if you want to do it this way, look, let's make this number bigger. So how can we make a quarter bigger? Well, we could, oh, there's a fly there. We could make 40, make it into 40. So it's 10 parts in 40. Then we could say it's 20 parts in 80. And then we could say 25 parts in 100. Okay, so we go 25. We do it again, look, put our 1 over the top. Oh yeah, 25 is 1/4. So we know, but that's a common one. We know that 0.25 is 25%, which is 1/4. The others, 7/10. What can we do here? We can times them both by 10 to get them to 100. When we look at that number, when we look at 70%, we're looking at our 1 again. Yeah, and we're saying 70%. Yeah, 70%. So 7/10 is 70%. 2 here. if we straight away, when we line up our number and we say, oh, 6.3 as part of 100, absolutely not, because it's over. So that's like saying 6.3 would be 630%. So that's wrong, because if it's less than 100%, the number has to be less than 1. So it's not. So that's incorrect when it comes to a decimal. Had that been 630, yes, that is correct. But the correct number for 6.3%, oh my gosh, I even said it. The correct number for 6.3 as a decimal is 0.63. Okay, so we got 0.63 for 63%. Had we looked at this number, if we're looking at that number, when we're looking at that number as a percent, it's just 6.3%. So way off. This one, 1/8. How to work out this one without a calculator? Well, if we divide 1 by 8, which we haven't got a calculator, but we can use a calculator, we'd find out, is it 12.5%? Well, let's just work it out. So we can work out, is it the equivalent of 1, come on, divided by 8, top divided by bottom gives us our decimal. Okay, so top divided by bottom, so 1 divided by 8 equals 0.125 as a decimal. Look at it as part of our 100. Okay. Aha, it's saying 12.5 pieces out of my 100. So 12.5 pieces out of my 100, this one's correct. Or we could just times that by 100, can't we, and move them 1, 2, so that becomes 12.5. But when you line things up with your one whole number against your decimal, you should be able to check in with it and say, oh yeah, it's right, 12.5%. Yeah, that's definitely an eighth. But again, once you start getting to 12ths and 8ths and 16ths, mentally, you're not meant to remember that. It's a case of just doing top number divided by bottom number to get your decimal. And there you go. Did we say those three? We didn't say that one. Well, we didn't actually tick. We did. We knew they were right. Okay. When we look at this one, quite a common kind of question when you get in calc, but at the front end of the calc, so not many marks. It might be worth 1 mark, this one, where you're having to look at, I think there's one about driving tests. The driving test A instructor had X amount of people pass his test, whereas driving instructor B, driving instructor C, driving instructor D, who had the most, who had the highest percentage of passing their driving test. So it's quite straightforward. Decimal first, but to get to a decimal, so fraction to decimal is top number divided by bottom number. Okay, then decimal to percentage is your decimal times by 100. But we don't need to go that far because we could tell from the decimal who's got the highest score. But it just says here, show me in percentages. So we're going to have to do both steps to then work out which one's got the highest mark. So this girl got 16 out of 25. So 16 divided by 25, we know she got 0.64, so that's a decimal. 0.64 times by 100 equals 64%. Okay, this young chap got 11 divided by 16. So this young guy got 0.6875. 0.6875. I mean, we could say straight away, actually, yeah, 0.68 is bigger than 0.64 because 8 is bigger than 4. However, we times it by 100 because it wants it in percentages, and we can see that this chap got 68.75%. So he got a higher, although she got more correct as a percentage of how many questions were in total, this man got the higher percentage correct. Let's scroll, and hopefully we got. This is a good one. Okay, it's just a real quick sort of looking at equivalents here and how to work them out, but we know that it's top divided by bottom. I do like a pizza. So we've got fractions, we've got equivalent fractions, and then we've got a decimal. As you can see, if we lined up, it says 9 pieces out of 100. So these two, this is just give me another equivalent fraction. So we could have said 90 out of 1,000, or we could have said 27 out of 300. Whatever you do with the top number, you do with the bottom number. When it comes to equivalence, you do both. You times both. So we just times them both by 2 to show you an equivalent fraction. But when it's saying 9 pieces out of 100, we should definitely just be able to say, oh yeah, look, that's showing 9 pieces out of 100, and that's saying 9%, so 9 per 100. That's percent. Percent is 100. Per is each. So percent is per 100. As kind of like break down a word, and you can see. Okay, correct. At last, we've got a third, 5/15, and then the proper percentage. So it's a crazy 33.33 forever, and then the equivalent decimal is 0.33 recurring forever. I think it was this one and this one that I see people get mixed up a bit more often. But again, 1/20th is not 20%. Think about it from this point of view here. We need to get this number to 100. So what are we going to have to do? We're going to have to times it by 5. Oh, we've done the equivalent fraction. And we times that number by 5. So we can actually, when you say 1/20th, it's 5 pieces in every 100. So that's why the decimal for a 20th is 0.5. Whereas 1/5, when we look at how do we get this number to 100, well, if we times it by 10, times that by 10, sorry, I'm writing really small here. We've then got 10 bits out of 50. And we can just double those, can't we? We can say it's 20 pieces out of 100. So an equivalent fraction of a fifth is saying 20 pieces out of 100. Let's line it up. Okay, we know that the zero's missing because we don't need to put a 0 on the end. But yep, I've got 20 pieces in my 100, therefore 1/5 is not 0.05 or 5%. 1/5 is 20% or 0.2. So those two, I would say, are common mistakes that people tend to overlook. They kind of, my brain works quicker than it should do sometimes in an assessment. So that bit of sort of error that it'd be me. I just overlooked it and I've gone really quickly. With this one, it's like the question again about if some people are having hot chocolate and tea, how many people are having coffee, make it up to 1. Okay, we've only got 2 to do here. So we could look at bits we need to collect to create one whole one. Or we could do more. Can we do more? I don't know. A fifth. Okay, a fifth. This could be tricky, couldn't it? Right, so we've got a fifth. That's that. And we've got to remember what this is. That's 20%. Okay. A fifth is 20%. So we know we've got 20%. And let's go 20%. Okay. Add 20%. I might be biting off more I can chew it. Add 20%. So that's another 20. So that's 20 and 20. That's 40 we're at so far. Okay, 40%. Okay, yeah, we got it here. Add, oh, yeah, we're good. Add 0.5. Right, so that's 50%. 0.5, that's a half. So half is 50%. So I'm now at 90, and now I can add 1/10 fraction in words, or I can go 10%. I've already got percentage. So let's go big. Let's go 1/10. So that is another 10%. So we have 100. In a classroom full of people, well, let's say full. When there's 9 or 10 people, it kind of throws out a challenge where we're looking at if somebody picks a tricky number, if somebody picked, I don't know, 99% straight away, then there's only one number on the whole of that board that can make it up to 100 because you've chosen such a big one to start with that it's the only one that matches to that one is that one. So that kind of spoils the fun when it comes to a classroom. So when we're choosing a number that's a bit smaller to start with, then we can start building things up, and it gets people's brain thinking, well, that's not right because that's a fraction. I'm just done it in decimals. Or that's not right. That says 1/10 in a word. But all of the time when we're thinking about whether it's a fraction, a decimal, or a word, I'm looking at what the equivalent percentage is because I can add 20, add 20, add 50, add 10 up in my head. I know that's 100. Can I add a fifth, 20%, 0.5 and 1/10 up in my head? Not as it is like that, but I change them to these numbers and then I can. So when we're talking about equivalence, some people are happy talking in decimals. So we'd have said, oh, can I write it on the top? Yes, we can. That's 0.2. Add another 0.2. Add 0.5. Add 0.1, which would have equaled 1 altogether. It's up to again, it's how you see equivalence. I like working in percentages because I like trying to get to 100. When I say, oh, let's get to 1, well, it's the same, isn't it? We're looking at 0.01 and 99%, that gets us to 1. But so I'm adding my numbers up to can get to 100. It's kind of like, well, not playing darts because darts is 1 to 20. But it gives people something to work at. And then we're looking at a fraction of where can I find, okay, and that's where they have to go off and find their own, make up their own. They got to grab a fraction. I mean, we can do one right now. Let's grab a fraction. Let's say, I don't know. I want thirds. Thirds are just not good to work with. Let's say we're going to go for, I don't know, 3. That's thirds in it again. 3/20. Okay, that's my fraction. So straight away I'm thinking, right, what is that in percentages? Well, to get that number to what I know what I'm talking about when it's over 100, I times it by 5. So I do the same with this one, times it by 5. So I know straight away I've got 15% here. Then I've got to think of a percentage. Okay, now you've done the fraction. The rest is quite easy because you can make these numbers up, can't you? So let's add 37%. Okay, so we know it's 37 there. It's still a percentage. 37, add 15. So we've got 37, 47, 52. So we're at 52 so far. What's the decimal that makes my 0.52 to get to 100 or 1? So it's 48%. Or, I'm going to write in my decimal box, 0.48. And playing around with that kind of old-fashioned fruit machine kind of numbers game, it gets, I mean, you don't see me on holiday playing these sort of games actually with my kids because they'd probably drown me in the sea. But it is good for kind of like just passing 5 minutes on where you're just thinking of equivalence and looking at how numbers are made up, and it gets your brain thinking sharper. But I say it's like if you play with kids, yeah, they'll probably disown me. So I play it myself, just do my head in my head. And that's a cool. I want to get to some proper. Okay, this is a good one, and it's non-calc. How do we find out percentages of a number when it's non-calc? We've had questions like this before where it's been like 13% or 21%, and I'm like, oh, it's going to take a while, but it's not. Because if we look at percentages, if we want 10% of a number, we simply divide the number by 10. If we want 1%, we simply divide by 100. We can do both of those in our head because that one means moving the decimal place one place in, and this one means moving the decimal place 2 places in without having to change any numbers. It's just placing the decimal place somewhere else. So once you know that if you work out 10% and you've got how to work out 1%, then it doesn't matter whether you've got 1 right through to 99. You can still work out that, because if you've got 10% and you know what it is and you times it by 9, that's 90%. And if you've got 1% and you times that by 9, you've got the 9%. So once you can work out the 10% value and the 1% value, then it doesn't matter what they throw at you non-calculator when it comes to finding a percentage of a number. It should be really methodical. Right, 60%. Right, so I need 60% of 50. Right, I know if I divide 50 by 10, I've got 10%. So 50 divided by 10 is 5. So 5 equals 10%. Right, I want 60. So to get to 60%, what did I do here? Oh, I times it by 6. Okay, so I'll need to do that side times by 6. So 6 times 5 is 30. So 30 is 60% of 50. Next question. So we've got 120. 15%. So let's divide it by 10 to get 10%. Okay, so 120 divided by 10, decimal place 1 place in, is 12. So if 10% is 12, okay, let's go what 5% is. So with this number, we halved it. So with this number, we've also got to half it. So we can see that 10% is worth 12, 5% is worth 6. We need 15. Add them both together. So that's 18. No calculator in sight yet. We've worked out 2 questions. Really quite straightforward, because we've learned how to do split a number into 10 equal pieces or split a number into 100 equal pieces. We've not had to do that one yet. We're not going to have to do that. We're just going to have to do the worst we're going to get is splitting it in half when you get 10%. 30%, really easy. 8 divided by 10 equals 8. That is 10%. We want 30. 8 times 3, 24. So when we're talking mental maths, we're talking how quick our brain relates the divide by 10 to, for example, 30% and 8 times by 3. Divide by 10 times by 8. So how quick can we relate? When it's a 0 on the end, when we've got our percentages, we're simply finding 10% and timesing it by the number of 10s we need. So 300 divided by 10 equals 30. 30 times by 8 is 240. So straight away, and again, if you're thinking, how did you work out 8 times 30 really quickly? I didn't. I just did 8 times 3. 8 times 3 is 24. Stick my 0 back on the end. So I don't know my 30 times table. I certainly don't know my 8 times table up to 30. I just literally know 8 times 3. Last one, 45%. So we got 160 divided by 10 is 16. We want 4 lots of that. So we're going to go 16 times 4. Again, 16 times 4. Do we know it off by heart? Not really, but 4 times 10 is 40. 4 times 6 is 24. So add those two together. I know that's 64. And that is 10%. So if I want 5%, so that's 10%. Well, 5%, I'm going to half that number. That's 8. So I'm adding that onto there. 72. That's 72. And then that one was 240. So we've not touched the calculator. I've probably gone over them really quickly, but those are the sort of questions that build into that question. Sometimes you might get a starter of a question that says, can you work out this part? Can you work out 21%? And again, once you remember that rule that if you divide a number by 10, it's 10%, and if you divide a number by 100, it's 1%. So all the time think of that. Percentages without a calculator. Wow. Okay, so we've got a question here. A jacket is on sale with 20% off. The original price is 80. So this is where when I talk to you about the 100% value, the number lines. I'm not a lover of I'm not a lover of number lines. I'm not sold on them that well. I get what it's saying. 80. Here, look, we've got. I mean, and when you're reading this, you might think, Steve, why don't you like number lines? They're amazing. It really works for me. Does that? Well, if it does, brilliant. We've got £80 for a jacket. We're taking off 20%. But for me, I'm just going 80 divided by 10 equals 8. That's 10%. Times by 2, that's 16. Take away 16 from 80. Yeah, we're going £64. However, if you see it as a number line like this, they've done exactly what I've done, but they've done it a bit more visually. So they've got 80 split into 10 equal pieces, so 10%. They've taken off 2 of those, so it leaves you with 80% of the jacket price. So 8 times 8 is 64. Again, it's how you've been taught. It's what you feel most comfortable with, and adapting your style to how you feel comfortable. Don't kind of change it because that's the way Steve said, because there's lots of ways to do things, and if you've got a way that works, absolutely use your way. Are we onto a calculator? Yeah, I think we might be onto a calculator. I mean, let's just not. Doesn't show a non-calculator sign anywhere here. A college is monitoring punctuality. 15% of learners were late to class at least once during the week. There are 2,500 learners. How many learners were late in the week? And I don't think it is calculated yet, is it? Okay, it's not, it doesn't matter. So 2,500. That's the 100% value, yeah, and we know that because it says that's the whole lot. 15% of these were late. 15%. So we know that if we divide it by 10, we've got 10%. And if we're going to find 10%, we move the decimal place one place in. So although it's a bigger number now, working with thousands, it's still the same principle. 250 equals 10%. I need 15. So let me half my 10. Half my 10. So I'm going to half my 250. Sometimes it's easier to half 250 than it is 25. But if you half 25, you know it's 12.5 because 12 over 12 is 24. So if I'm halving 250, I'm halving exactly the same as that. And so I know that's 5. Add those both together. That's 15. Add both these together. That's my 15%. So 375 pupils were late last week at least once. Wow. And get some attendance going now. School will be ringing if it's my daughter's school. 5 minutes late. Where's your daughter? She's on her way. And percentage of the amount. Jack saved 20% on his monthly wage. Jackie's paid £900 per month. How much does he save a month? How about a year? So this question is from an exam, but it's that bit isn't in the exam. This bit is just the exam part. I'm not sure if this is, maybe it's not calculator. Have I got, no, it doesn't say anything about calculators yet, but if we're using calculators, then if we look at this, I mean, we'll do it without a calculator first, because I don't know if it is a calculator question or not, and then we'll have a go with a calculator, and I'll show you how much, not time you save, but how easy it can be. So Jack saved 20%. So we're going to go 900 divided by 10, bounce it in once, equals 90. So 20% again, so we need 20% is going to be 180. So he saves £180 per month. Okay. How about a year? So 180, a year is 12 months. So if we times it by 10, 1,800. That's 10 months. Okay. Now another 180. Another 180. We've got 12 months. 0, 0, 0. 0, 8, 8. That's 16. 8, 1, 1. That's 10. Another one, 11. £2,160 he saved in a year without touching a calculator. However, if we could use a calculator, then I'm straight away looking at that as a decimal. Because if I've got my 900 and I times it by the equivalent decimal, remember, 20 is 0.2, not 0.02, that'd be 2. So 0.2 is 20%. I've now got straight away, without doing my 10% and then my 20%, I've now got my 10% value, my 20% value, sorry. On the calculator, 900 times by 0.2. 2. Done. 180 times by 12, 2,160. So it's 2 steps in a calculator. Times by 12 equals 2,160. Sometimes people would see this as 2 times 9 is 18. So you've got your 20% straight away, which is 180. But again, break it down the way you feel comfortable. I break it down because I feel comfortable finding out 10%. Then I know I can find out 20%, just double it, and then I just times it by 12, but I didn't. I times it by 10 and then added the month 11 and month 12 on. So all of that using a calculator. It just sometimes takes a little bit longer doing your own way. But when I say it takes a bit longer, what, 5 seconds longer, 10 seconds longer? Right. This one also non-calc. Is this one non-calc? I don't know. We can certainly work out with non-calc and we finish off with a calc to check we've got our answers correct, I think. There are 640 fans attending a local rugby match. 35% of the fans are women. How many men attended the match? I mean, if I'm looking at that, you might be thinking similar. If it's 35 women as in percent, then it's going to be 65 men. So do I want to find out of 35% and take it away from that, or do I want to straight out find out what 65% is of that number? I want to find out straight away what 65% is that number. Okay, I can find out 35% and take it away. But if I find out straight away what 65% of that number is, I know that's the other part, because that's the other part that I meant. So I'm going to go 640 divided by 10, which is 64. Okay, 64, and I need, now don't forget, I need 3 lots of those. Oh no, I need 6 lots of those, so I'm learning this one. Oh my gosh, I'm going to times it by 6 then. That's not good. Times it by 6. Where are we at? Times it by 6. And I know I need the extra 5. I know that, but I'm going to in a minute. Times by 6. 4 times 6, 24. 6 times 6, 36, 38. So that's 60% is 384. However, I need another 5%. So I know that 10% is 64. So 5% of half that number. So I need to half that number, 32. Add that onto my spare here. So 384, add 32. 6, 11, 416. Without a calculator, a 2-minute question or a 2-minute question. With a calculator, again, it's how you recognize whether you want to work out 35% or whether you match that in your head to if 35% are ladies, then 65% are men. If I've got 65% as a decimal, I'm changing it to 0.65. If I put my 100 above, I can see, yeah, that's 65 pieces out of my 100. So if I know that my equivalent decimal is 0.65, I've got this number of total fans. I want to know what 65% is, because that's men. I'm going to multiply it as one sum, one-off sum, and I'm hoping I get 416, or so that's going to be my maths out of the window, isn't it? 640 times by, that's why I like to do these lessons live, because it's so much fun. If I get questions wrong, I don't mind. I just got to type to let everyone know what we're doing. Times by 0.65. 416. Phew, sigh of relief. Equals 416. Had we have worked out 35% first, then we could have done 640 times by 0.35, right? 640. Sorted out as their equivalent. It's the percentage. The decimal is 0.35 times by 0.35. I'm going to plug my mouse back in. It's getting a bit rogue. It's moving across the page as I speak. 224, and then we're going to take our original whole people, take away the ladies, and that'll equal the men. And so we got 640. Take away the amount of ladies we've got, 224, and we've got the same number, 416. So 3 ways to do that. Because it doesn't say calc, I'm not sure. I think this one was a calc. I can't remember off the top of my head. But where it's fairly straightforward percentage numbers, we can work out 10%. Or we can recognize the equivalent decimal, like we did up here, and just work out the amount we need rather than take it away. But neither way is going to take you much longer. Whichever way you do it. Here's this one. This one's a justification. Okay, an exam has a total of 80 marks. A student needs 60% of the marks to pass. So when we're thinking 60%, remember that equivalent decimal table. So we've got 60 out of 100 is 60%. We've got 60% is the actual value as a percentage. So that's the fraction. That's the percentage. That's the decimal. The decimal, 60%. Oh, it's 60 pieces out of 100. There's my 60 pieces out of 100. I can just multiply my 80 by 0.6 to know what 60% of 80 is. Or if we're quick thinking, we could do 6 times 8, and that would give us the same, because that would give us 60%. But let's not do that. 80 times by 0.646, 48. So we know that 60% of that number is 48. When I said, oh, we could do 6 times 8, but don't worry, it really works. Not for every sum. Obviously it does, but for the easy ones, when you're looking at one's numbers, we've got zeros on the end here, then yes, we can times the 2 numbers together to give us what that number is going to be. But when it's like 64 marks and 41%, it doesn't really work like that. So again, the more comfortable you get with different numbers, then yeah, absolutely recognize that. But without it being zeros on the end, it's not as simple as that. So when it's got a 0 on the end, yeah, it's quite straightforward to times the 2 numbers. Sasha got 46. Did you pass? Unfortunately, no. Not passed. And it's 48. Actually, not 48%. It's 48. So that's incorrect as well. Right, we got pleasure amount. Hamza pays £48 on his phone contract. The network provider offers Hamza a 35% discount if he renews his contract. How much would Hamza pay after the discount? What are we thinking? We can do it without a calculator? Of course we can. It doesn't say again. I'm not sure. I need to look back at my classroom notes if I'm allowed to use a calculator or not. He's going to get a 35% discount. Well, did we have it above? Well, we had 35. So what's the equivalent of 35? If we're getting rid of 35, we need to keep 65. So he's getting a 30. That's quite a good discount. Is that on my phone contract? I might be doing that. If we get a 35% discount of the amount, we want 65% because that's how much he's keeping. So if we find out 65% of 48, we've cracked it. Because that is 48, take away 35% because they're leaving us with 65. So how are we going to do that? Well, we're going to go 48 divided by 10 equals 4.8. Okay, and we're going to do the same again as we did last time. We times it by 6. Okay, pen's getting a little bit. Okay. 8 times 6 is 48. Let's get a decimal place in there. 4 times 6 is 24. Add our spares is 28. So we know that 28.8 is now 60%. We need another 5. So what's half? So if we say 4.8 equals 10, we want 5. Half of that number, so we do split it in 2, so that's 2.4. We've got another £2.40 added into there, so 28, £2.40. That becomes a 12. That becomes a 10. That becomes an 11. And then we've got another one. So £31.20 is Hamza's new contract price. With percentages, again, if it is a calculator question, then yeah, don't think, oh, Steve showed me how to do it non-calc. I better do it that way first. If it's a calc question, straight away get your calculator out and do it. It'll take much less time. So we can do 48 times by. Sorry, maybe you can't do it as quick because I'm going to put my mouse. I'm going to grab my mouse because it's deciding that the battery's getting a bit low and it's not responsive. All right. Come on. Maybe I'm not. There we go. Plugged in. Right, we're back. Times by 0.65. So without any other workings out, we've got £31.20. And as much as it didn't take that long to do via non-calc, if it's a calc paper, you might as well just use a calculator because 10 seconds you're at the other side and you're working out the next part of the sum, whether it's compared to another deal that you can get on another phone company, or if he needs, wants to work out how much you can save over 2 year worth of a contract. So the start points of a question, if you are allowed to use a calculator, absolutely do it. Right, 8% as decimal. Questions where you won't get questions like this in an exam, you might get a number and it'll say, oh, can you show me this as a percentage and as a fraction, and you have the decimal number. So quite often it won't be just decimal. It'll show, can you show it as a multiple kind of number. Yeah, we know that. We just divide it by 100. So divide it by 100, 8%. Okay, when we're looking at it as a decimal, I'm lining up my 100 and I want 8% of it. So when I've got my 1, yeah, that's my decimal, 8 parts in 100. 21.9. That's different, isn't it? Because of my 100, I've not got the point bit at the end, so I have to put it there, aren't I? I've got 21.9. However, when I divide this one by 100 to get 1, I divide this one by 100, I get 0.219. So basically you're moving the decimal place twice to the left. Twice to the left on 2.5, 0.025. Twice to the left, you've got 0.756. All decimals, all done by dividing the number by 100, and all done by moving the decimal place 2 places to the left. If we're wanting to match it, as in just to make sure we got it right, line it up against when you would write 100 or 1.00, and check how many pieces you've got. So for that last one, let's line it up against 100. We've got 7, 6, and 7, 5, and 6. Oh, yeah, we're right. Look, because that's my 1. That's where my 0 will be. Yeah, all good. I've got 75 pieces and a 6 at the end out of 100. Exam question. Oh, we got an. Is this? Okay. Is this? No. Okay. We're okay. We'll do one of these. We've got 4 minutes left. So this is from an exam. Alex says the probability that the score is negative. Oh, the probability that the score is negative is 0.5, which means there is a 5% chance. I was thinking that doesn't make sense, and that's why it's incorrect. Okay, so it's last thing on a Friday, and words are confusing me. There's a surprise. 0.5 as a percentage equals 50%. Okay, that's why I'm thinking, have I done a typo? I was reading ahead in the question without actually reading the question. I'm thinking, gosh, I've made a mistake. So it's asking why is incorrect, because 0.5 is actually 50%. Or if you say 5% is actually 0.05. Remember that 100 above? 5 pieces. So that's why he's incorrect. And I'm thinking that, yeah, sorry, I was kind of half covering up. Maybe I've made a typo. Let's do one more because that one was a little bit bit straightforward for, well, not a little bit, yeah, straightforward for the last thing on the Friday. Write the following values in order, size first. It doesn't say don't use a calculator, so I am presuming we're allowed to use the calculator. When they're all in decimals, we can order them. So 47% is 0.47. We've got that one and that one already. We know to change a fraction to a decimal. Hopefully you're all shutting your computers now, saying top number divided by bottom number. 5 divided by 9. 5 divided by, why is it doing that? 5, maybe it just needs a reboot. 5 divided by 9. 0.555. Okay, so we can just put 0.55. And the last one, 4 divided by 7. 4 divided by 7 equals 0.57, 0.57. Put these in order with the smallest value first. When you do an exam like this, because there often is questions like this, do not write them in the order where you've changed them all to decimals. You must use the original values. So as we can see here, and that's 57, not 37, by the way. 47% is the smallest. So we'd say 47%. We write it as we see it. The next one along, 0.5. We see it as the next one along, 0.53. And then the next one along is 0.55. However, it was placed as 5/9 at the start. And the last one, 0.57. However, again, it was stated as 4/7. So when you've got the place, the order of numbers, yes, the examiner can see you've put them in the right order, but you've changed your numbers. So if you get a question like that, change your numbers back to how you first saw them. Right, I think, wow. Isn't it amazing I can do 3 hours in 1 hour, mate? I wouldn't tell this to my group because they'd be like, Steve, you make us sit for another 2 hours and do this. Let's get rid of this. Right, let's stop recording. I just want to